Thank you for joining. In this lesson, we will continue practicing routes and constraints. This lesson will be dedicated to custom constraints, including the extension of logic using the IRouteConstraint interface to verify received URL data in ASP.NET Core 7. If you recall the diagram from the previous lesson illustrating how a constraint works, the process for custom constraint will have almost no differences. We will simply create a separate file with custom logic where the entire process will take place. As you remember from the previous lesson, moving custom logic outside of the main file, where an if statement or any other language construct is used, is highly preferable. To create a new folder, follow the usual steps in the Solution Explorer, right-click and choose Add New Folder. Then add a class file by right-clicking the newly created folder and selecting Add Class. You can name the folder and the class file as you prefer. For demonstration purposes, it will be a custom constraint folder named custom constraint, and within it, a file named custom constraint using the predefined class template. To implement a custom constraint, we need to utilize the IRouteConstraint interface. Let's take a quick look inside the interface to see what it offers. Within the interface, we find a method named match. The match method returns a Boolean value that is used to indicate the validity of the route parameter's value. When the value is valid, the method should return true. Conversely, if the value is not valid, the method should return false. The other 5 parameters of the match method are used to provide context about the route and the value that is being validated. The HTTP context parameter provides information about the current HTTP request. The route parameter provides information about the route that is being matched. The route key parameter provides the name of the route parameter that is being validated. The values parameter provides a dictionary of route values. The RouteDirection parameter indicates whether the route is being matched in the request direction or the response direction. The match method is called by the routing system when a route is being matched. The routing system will call the match method for each route constraint that is associated with the route. If any of the route constraints return false, the route will not be matched. So the bool type, which is return type of the match method, is a simple and efficient way to indicate whether the value of the route parameter is valid. And about RouteDirection parameter. For now, I will explain briefly how it works, but with further lessons we will discuss it in more detail. The RouteDirection enum is used by the routing system to determine how to interpret the route parameters. For example, if the route is being matched in the request direction, the RouteDirection parameter to the match method will be incoming request. This means that the value of the route parameter should be interpreted as the value that was received in HTTP request. If the route is being generated in response direction, the RouteDirection parameter to the match method will be URL generation. This means that the value of the route parameter should be interpreted as the value that should be used to generate the URL. So, incoming request when a route is being matched in the request direction, this is the most common case. And URL generation when a route is being generated in the response direction. This is used when generating URLs for links or redirects. So that's the signature of the IRouteConstraint interface. And to implement it, we need to click the right button and choose Quick Actions, then implement the interface. After it's implemented, I will quickly add required logic and will explain it as soon as it's ready. Now let's see what is happening here. This code or custom constraint code validates the value of a route parameter named year to be one of the years 2023, 2024 or 2025. It validates it because this reference years is registered with the builder using ConstraintMap method. So the parameter year refers to the name years registered with ConstraintMap, and year parameter should be available in the URL to get it triggered. The custom constraint class has 2 private fields. One is years, it's a dictionary that stores the years that have been validated, and JSON file that is used to store the validated years. The match method of the custom constraint class first checks whether the route parameter year exists. If it does not exist, the method returns false. If the route parameter year exists, the method uses a regular expression to validate the value. And also using regex, it matches any string that starts with the characters 20 followed by 2 digits. If the regular expression matched the value of the route parameter, the method records the validation result in the years dictionary. The method then serializes the years dictionary to JSON and writes it to the JSON file. And finally, the method returns true to indicate that the route parameter is valid, or it returns false if the logic inside of an if statement hasn't passed the test. Previously, I mentioned the need to register a custom constraint. Registration involves assigning it a name and attaching it to the builder. In this case, the reference name is years. To achieve this, we declare typeof with the custom constraint class and its corresponding namespace. Following this registration, we can utilize it with our code using the reference years. So at this portion, month and year, we see that the reference years has transformed into a custom predefined constraint that we constructed. The years segment utilizes a custom constraint, and the month segment it's a built-in type int constraint offered by ASP.NET Core 7. As I discussed in the previous lesson, we have modified our previous code to incorporate a custom constraint. In doing so, we have created a distinct, reusable file that performs multi-level verifications using if statements and regular expressions. This file with the custom constraint can be further developed if necessary, offering a convenient method to validate front-end received data and furnish supplementary information to clients as needed. Furthermore, as our present logic entails file creation, the upcoming lesson will focus on the public static folder and public files. And as always, lesson assignments. In this lesson, I will not execute this code or create a JSON file. Instead, it will be your task to reconstruct this code, execute it, and observe the creation of a JSON file after accessing a URL with recorded parameters. The generated file should become visible in the Solution Explorer, and it will contain the URL data. At the conclusion of each lesson, I highly encourage you to complete the assignments, as they will greatly contribute to your progress in ASP.NET Core 7. By consistently practicing, you will see faster results in your learning journey. And the assignments answers you can download from the GitHub. The link is below. Thanks for watching. If you have any questions or need further assistance, feel free to comment below. Don't forget to hit that like button and subscribe to our channel for more great coding content. Stay updated with the latest videos by ringing the notification bell. Happy coding!